Welcome to my channel and thank you for watching the videos. In this video, question 11b of 1992 UPSC CSE Maths Optional Paper 1. This question is of statics, and in this we have to define central axis for a system of forces acting on a rigid body. A force F acts along the axis of x and another force NF along a generator of the cylinder. X square plus y square is equal to a square. Show that the central axis lies on the cylinder. This equation of cylinder is given: n square into nx minus z whole square plus 1 plus n square whole square y square is equal to n to the power 4 a square. So this is a question of statics and equilibrium of forces in 3D. So first we have to define the central axis, and we know a few definitions related to central axis. Any system of forces acting on a rigid body can be reduced to a single force together with a couple whose axis is along the direction of the single force. So we know that we take OA, this is, and then this is 90 degree, B, this is x-axis, we can see that these OA, OB in one plane perpendicular to this OC, and the direction of couple is this one OD. Then we can say that couple of moment G about OD is equivalent to couple of moment G cos theta about OA and G sin theta about OB. So we can define it, and with the help of this we can show that we can derive it, that system of forces acting on the rigid body is equivalent to a single force R acting along a line O dash A dash. We will have one O dash A dash here, and a single couple of moment G cos theta about the same line O dash A dash. That we can define, but here we have to define the central axis. And central axis is, definition of this, the line along which the single resultant force of magnitude R acts, and which is also of the couple of the single couple of moment G cos theta to which the system of forces acting on a body is reduced is called the Poinsett central axis of the system of forces. There are two characteristics of central axis. That first is central axis of a system of forces acting on a rigid body is unique. Second is the moment of resultant couple with a point on the central axis as the base point is less than the moment of the resultant couple corresponding to any arbitrary point O which is not on the central axis. So these are two characteristics. Now we come to the question. Here we have a cylinder. This is x-axis, y-axis and z-axis, and this is the generator. Of the cylinder. Then we have a point here. A's coordinates are A cos alpha, A sin alpha, 0. A cos P is on OX. This is the force. And NP on generator. So we have here one force, that is P, is acting on x-axis, and its equation, because it is passing from 0 0, so we can write, and its DCs are 1 0 0, so we can write the equation x minus 0 upon 1 is equal to y minus 0 upon 0 is equal to z minus 0 upon 0. And another force NP, that is acting along a generator of the cylinder, x square plus y square is equal to a square. So clearly this generator of the cylinder, this is parallel to z-axis. So generator is parallel to z-axis. And this force NP is acting along AB, and here it is passing through the point A, which is A cos alpha, A sin alpha and 0. And DCs of z-axis are 0 0 1. So we can write it is passing through A, and DCs are x minus A cos alpha upon 0 is equal to y minus A sin alpha upon 0 is equal to z minus 0 upon 1. So there are two forces which are acting on the body. First is force P is acting on or at the point 0 0 0 along the x-axis, and second is NP force, which is acting along AB, and A's coordinates are A cos alpha, A sin alpha 0, and along the generator AB. So DCs of this generator AB is 0 0 1. So there are two forces. So we can find out components x1 y1 z1 x2 y2 z2 of these forces parallel to the axis. So we are finding out the components x1 y1 z1 x2 y2 z2 parallel to the axis. So it is x1 is p into 1, y1 is p into 0, and z1 is p into 0. And x2 is np, this is force, into dc, which is 0. y2 is np into 0, and Z2 is NP into 1 0 0 1 1 0 0. These are the DCs. So if the system reduces to a single force R, which we can write down XYZ acting at a point O, and a couple G we denote by LMN, then we can write down X is equal to X1 plus X2 is equal to P, Y is equal to Y1 plus Y2 is equal to 0 because both of them are 0, and Z is equal to Z1 plus Z2 is equal to 0 plus NP is NP, and L is equal to sigma R is equal to 1 to 2 YR ZR minus this YR, this is the coordinates and these are the components of the force, capital one, small zr YR, which is equal to Y1 Z1 minus Z2 Y2 plus Y2 Z2 minus Z2 Y1 Z2 Y2. So this comes 0 minus 0 because Y1 is 0, Z1 is 0, Z2 is 0, Z2 is NP into Y2 is 0. So here we can write down X1 Y1 Z1 is, this is X1 Y1 Z1, and X2 Y2 Z2 is A cos alpha, A sin alpha and 0. So think of this, Y1 is 0 and Z1 which is the component. These are the component. So Z1 is also 0, Z2 is 0 and capital Y2 is 0. So 0 plus Y2, this is the coordinate A sin alpha, and Z2 is NP minus Z2 is 0 into whatever is Y2, that is also 0. So this is L. Now we find out M. Sigma R is equal to 1 to 2 ZR XR minus XR ZR, which is equal to Z1 X1 minus X1 Z1 plus Z2 X2 minus X2 Z2, and here Z1 is the coordinate which is 0 and capital X1 is P, that is 0 minus X1 is 0 into Z1. So this is 0 plus Z2 is A sin alpha into capital X2 is 0. So 0 minus X2. X2 is A cos alpha and A cos alpha into NP, because you can think it in this way also. A cos alpha into NP is equal to minus A NP cos alpha. Now we find out N. N is equal to sigma R is equal to 1 to 2 small xr yr minus yr xr is equal to x1 y1 minus y1 x1 plus x2 y2 minus y2 x2, which is 0 minus 0 plus A cos alpha into 0 minus A sin alpha into 0 is equal to 0. So the equations of central axis are L minus yz plus zy upon x is equal to m minus zx plus xz upon y is equal to n minus xy plus yx upon z. So this comes a and p sine alpha minus y into np plus z into 0 upon p. Here if we think this is L and y is z is np and z into 0, because capital Y is 0 is equal to m is minus a n p cos alpha, this is capital M, minus z into x is p, because total resultant we are taking, and plus x into np, because z is total is np, upon 0, because y is 0, is equal to 0 minus 0 is n is 0, x into 0 plus y into p upon np. So if we simplify it, it comes a n sine alpha minus y n upon 1. P has been cancelled out, is equal to minus a alpha cos alpha minus n x minus, plus we can write down plus minus z upon 0 is equal to y upon n. So these are the three equations. We will solve these equations. We will eliminate alpha from these three equations. So when we take first and second equation, first two equations we are taking, then we get minus a n cos alpha plus nx minus z is equal to 0, because when we do cross multiplication, only one term is there, that is 1 into minus a n cos alpha plus nx minus z is equal to 0. So when we simplify it, it comes a n cos alpha is equal to nx minus z. We can say this is first equation. Now from first and third equation, which we had three parts of the equation, then we can have a n sine alpha minus y n is equal to y upon n. So from here we can write a n sine alpha is equal to y upon n. Alpha is, this is n square plus 1. N square plus 1. This is equation 2. And when we square and add these 1 and 2, we get a square n square cos square alpha. Left hand side we are taking sine square alpha. Right hand side is nx minus z whole square plus y square upon n square plus 1 whole square. So simplify it, n square nx minus z whole square plus 1 plus n square whole square y square is equal to n to the power 4a square, and this is the required surface. Thank you.